Well, hello. Down here at Southbourne Beach, and as you can see behind me, there's some beach management going on. Here we've got an example of the groins down at Southbourne actually being replaced. These are typical wooden groins, and these groins are an example of hard engineering and last typically 20 to 25 years. You can get steel ones which last a lot longer, but these groins are picked for their aesthetics, the way they look. And down at Southbourne they've gone with the wooden ones because they don't put off tourists, and they are fantastic at trapping the sand. Okay, so here we are again. We've got down by the shore front now, and here you can see, I'm going to talk you through Longshore drift. And the two main important things about Longshore drift is, one, the swash of the wave, and two, the backwash of the wave. Now the swash of the wave you can see as the wave comes into the shore, and it occurs at a 45-degree angle and gives sediment its movement along the beach, whereas the backwash goes directly backwards at 90 degrees back out to sea, taking back with it any sediment that is caught up in the backwash itself. Just like I just spoke about the swash and the backwash of the wave, I thought I'd draw a little diagram of it. So you get the swash coming in at a 45-degree angle going into the shore. Now any sediment that is picked up by the waves gets taken inland up the shore, and then it comes directly back via the backwash. Now the backwash occurs at a 90-degree angle, coming straight back out towards the sea, and the sediment gets dragged with it. It will then get taken back in the swash, back up the beach. The sediment then gets taken down 90 degrees again by the backwash, and this process occurs until it moves all the way down from this side of the beach, all the way up to get trapped by one of those groins. The power of the swash and the backwash is dictated by the conditions at the beach. Now, in a much calmer environment, just like we've got at Southbourne, the waves are predominantly constructive waves, and this means that the swash is much stronger than the backwash. So a lot more sand and sediment is left at the top of the beach, and a lot less is taken away. Now, in a much windier environment, you're going to get much more powerful waves. These will be waves with a much higher wave energy, a much higher wave height, and a higher wave frequency. Now, these are destructive waves, and they have a much more stronger backwash than they do swash, which means any sediment that's left on the beach is taken straight back out to sea. Okay, so let's see a demonstration. So with Longshore drift, we should be finding that it's going in an easterly direction towards that groin. So I'm going to throw this ball in. I just want you to see what happens. Now straight away there you can see the importance of the prevailing wind. The prevailing wind gives the swash its direction, and it's taking it towards an angle away from us, heading towards the groin on the far side. The backwash then took it straight back 90 degrees, straight back out to sea. Now it's really important to realise that the swash isn't always at 45 degrees, it's at whatever angle the prevailing wind is going, but this will be an oblique angle. And oblique basically means that it's an angle that's not 90 degrees, so it's not heading in a straight direction, it is heading towards an angle, often towards a groin that will then trap the sediment. Now again there we've just seen in the swash, the ball moved further away from us, and then the backwash took it straight back out. Okay, Longshore drift then has moved sediments just like this, all the way along the beach in an easterly direction. Now it's gone east because of the prevailing wind, and the wind gives the swash its direction and move the sediment along the beach to be trapped by this groin here. Now you can see on this side of the groin, it's really built up, but just on the other side you can see sediments being taken away to be trapped by the next groin. Look at the difference. So much lower. Now, over time in Christchurch, we can see that there are many groins along the beach, and these have been incredibly effective at trapping the sediment, as can be seen there. Now, around this groin, there's been a huge weight of sediment that's been trapped and stopped via Longshore drift and built up the beach, so it's a real effective defence for those cliffs behind. The Longshore drift, however, being stopped, has resulted in these beaches here being starved of sediment and the cliffs here being rapidly eroded. Now let's have a look at an exam question. This exam question is going to be a 6 marker, and Mr. Smallman in his video will talk you through how to answer it effectively.